Next, we have to consider what is an absolute value inequality. We already know how to graph the solution set to a simple inequality, and this one is really simple, x less than or equal to 2. We already know from set builder notation that we have to write this solution set officially as all real numbers that are less than or equal to 2, and the graph is 2 and everything less than 2, and we put a filled in circle because 2 is included because of the equal sign. Now we have to discover what would happen if we put absolute value bars on the x and tried to solve it. Let's start with absolute x equals 2 and go from there. We already know that when absolute x equals 2, x could be 2 or x could be negative 2. You're allowed to put 2 inside of the bars. You're allowed to put negative 2 inside of the bars. The answer comes out as a 2. Since our inequality was less than or equal to 2, we're allowed to put these two numbers in the solution set. I graphed them over here. Now that we know where absolute x equals 2 is true, the question is, what about the other numbers on the number line? What about where absolute x is less than 2? Is that possible? One thing that you can do is make a little chart in your mind of what x's look like in each of the three sections of the number line that are not 2 or negative 2. Here I chose -6, -4, and -2.1, and when I put them into the bars, they came out positive, and when they came out positive, they were too big. So if x, before it goes into the bars, is less than -2, it comes out of the bars too big. So this is a no. In the middle, however, and I chose -1, 0, and 1.999, I tried to get as close to 2 as I could. When they went into the bars, they came out as +1, 0, and 1.9999, and yay, they are less than 2. These numbers are less than 2, and because these numbers are less than 2 when they come out of the bars, or with the bars on them if you want to think of it that way, these numbers between -2 and 2 make this true. So, what about these numbers over here? Well, if they were too big before they went into the bars, they're certainly going to be too big when they come out. So if x is bigger than 2 without bars, it's going to be bigger than 2 with bars. So it looks like if we put all the pieces together that we just analyzed, that the solution set for this inequality is all the real numbers from -2 to +2. If you are a visual thinker, this might seem obvious to you that it would be from -2 to +2. Absolute value bars can be used to measure the non-negative distance, which is why you use bars, because distance is not negative, on the number line from 0 to any number on the number line. That means that when you're asking for this inequality, you're asking for all the numbers that are 2 spaces or less from 0. So here's 0, 2 spaces forward, 2 spaces backwards. If you're 2 spaces or less, you're exactly in the same place you were in when we tested the numbers. The opposite of being less than or equal to 2 is to be bigger than 2. So what happens when we try to sort out bigger than 2? Well, the first thing I did, thanks to Vo, is I made these open circles, because now that we have greater than, we're not allowed to use -2 and 2 anymore. But what about the numbers that are here, here, and here? Well, obviously these are out. If they make it less than, they can't be greater than. But going back to these two sections, the things that made it bad for less than makes it perfect for greater than. So we now have, oh, I got ahead of myself. If you're a visual person, you're looking for numbers that are more than 2 spaces from 0. So more than 2 spaces from 0 are on this end of the number line or on this end of the number line. So either way, if we want greater than inequalities, we want to be on the ends of the number line. So here is the solution to absolute x greater than 2. All real numbers that are either down here or up here. This pattern will always apply. Less than absolute value solutions are in the middle of the number line. and greater than are at the ends. Let's check out one more, example 3. Absolute 2x plus 3 is less than 5. The analysis part says that because I have a positive number over here and a less than over here, I want to be between negative 5 and 5. So I put 2x plus 3 in the middle with negative 5 on one side and positive 5 on the other. I subtracted 3 from all three sections, then I divided by 2 and ended up with this inequality. The graph looks like this. The solution set in set builder notation looks like this. And again, I made sure I had open circles here because I had a less than and not a less than or equal to. And all less than absolute value equations are in the middle of the number line. So here's my graph in the middle of the number line between one arrow on one side and one arrow on the other. Now you get to try the next example. In order to know for sure what your absolute value is doing, you have to sort of sort things out because I kind of buried it in here in the middle of all this extra algebra. So the first thing you're going to want to do is get rid of these extra numbers algebraically to sort out what x minus 2 is really doing. And once you know what x minus 2 is really doing, you can actually go into your analysis and solve the problem. I gave you my solution set over here. I'm pretty sure I'm right, but if you find a mistake, I'm always happy to hear about it. And if you think you've made a mistake, again, don't come to class and ask me what you did wrong. Figure it out for yourself. You'll never get really good at this stuff if you can't figure it out for yourself. I can't help you on the math tests. I can't help you on SATs and ACTs, so learn to help yourself. That's the best guarantee of success.